All right, welcome to the 2C 2D test review, which is absolute value, graphing absolute values, functions, and inequalities. All right, so number one, we need to graph, it's an absolute value function, so it's a V. We then need to think about our vertex, the bottom of the V. So parent function starts at 0, 0, and where's that going to move to? Well, my x minus 2 means right 2, and then the minus 3 on the outside means down 3. So we're going to move the vertex right 2, down 1, 2, 3. There's our new vertex, so I'm going to erase the old one. Now let's look at the slope. So slope is on the outside actually. It's right after the equal sign, it's the dilation. There's a negative there, so I'm going to put a negative 1 over 1. So from the vertex, I'm going to go down 1, right 1. Down 1, right 1, down 1, right 1. That only forms half of the V. The other half is down 1 and left 1, so you can go either way. So down 1, left 1, keep that pattern going. And it's an equal to sign, so it's going to be a solid line. Solid line. So there's our graph. Now domain, let's think about domain. Domain is the x values of the graph. How far left will the graph go? Well, it's going to keep going left forever, and left forever on the x-axis is negative infinity. So the domain is going to be negative infinity. And as it's going to the right, how far right will it go? It'll continue to the right forever. Right forever on the x-axis, because domain is x values, is positive infinity. Now range, let's look at the range. What's the lowest y value? So y values, think about the y-axis. Y values are lowest points to highest points. On the actual graph, the lowest points, both the left end of the arrow and the right end are going to go down forever. So down forever is negative infinity. And what's the highest coordinate? The tall is the highest one. It's the vertex. And that point is at 2, negative 3. Now we're talking range. So we want the y value. Range is the y value. So negative 3. There's an actual point there. It's a filled in point. So that's going to be a bracket. And there's your range. Zeros, where's it across the x-axis? Well, it doesn't cross the x-axis anywhere. So we put none. The y-intercept, where's it across the y-axis? Well, it crosses the y-axis here at 1, 2, 3, 4, negative 5. All right, there you go. All right, let's do number 2. So we got to first find the vertex. So right 2, well, it's the same as the last one. Up 1, so right 2 and up 1, so there's a vertex. And now let's look at the slope. So slope is 4 over 3. So I'm going to go from the vertex up 1, 2, 3, 4, and to the right 3. And I'm also going to go up 4 and left 3. And you can keep going up 4 and right 3, and up 4 and left 3. And then you get, it's an equal to, so it's a solid line. I keep saying that because in inequalities, that's important. Okay, so now let's look at domain. How far left will the graph go? Well, it'll continue left forever. It's negative infinity. How far right will it go? The x values are going to continue to the right forever. The range is lowest point to the highest point. So the lowest point of the graph, the lowest point is here. The x value is 2, the y value is 1. We're talking range, so we want the y value. So it's at 1. Now there's an actual closed point there. A closed point means equal to. Equal to is bracket. So 1. And then how high will the graph go? What's the highest y value? Well, both the right end and the left end are going to continue up forever to infinity. Zeros, where's across the x-axis? Doesn't, so again we say none. The y-intercept, where's across the y-axis? I'm going to estimate it to be 3.75. Anywhere around there is pretty good. 3.75. Number 3, find the equation of the graph of the function graph below. Okay, so here we got to find the vertex first. So the vertex is here at -5, 0. So from 0, 0 from the origin, where the vertex of the parent function is, we went 1, 2, 3, 4, 5 left. So left 5. There's no up or down, so we know in the equation we're going to have y equals a left 5, so x plus 5. There's no up or down, so no plus or minus on the outside. Next, we look at the slope. So I'm going to go along the line and along the V and find our next points. So you could have went there, here, doesn't matter. So from the vertex, let's go up 1, 2, 3. So it's going to be a slope of 3 over 1 to the right 1. So 3 over 1. So 3 over 1 is 3. And there's our equation. Domain, how far left to right? So it's going to be -infinity to infinity. The range, the lowest y value is the vertex here is at 0. There's an actual point there, a closed point, so 0, and how it keeps going up to infinity. The zeros, there is a 0 here. Woo-hoo, it's -5. It crosses the x-axis at -5. This is where it touches or crosses. The y-intercept, I don't know, somewhere up here. What would that be? Let's say about 14. I'm just estimated that. All right, next one, equation. Look for the vertex. Vertex is at 2, 3. So that means it was right 2 and up 3. So we got to put that in the equation. So y equals right 2 x minus 2 and up 3. Next thing is look for the next coordinate. That would be nice. Looks like here or here. And what would the slope be? So it's down 1, 2, 3. So it's going to be -3 over to the right or left 2. Doesn't matter. Right or left, don't go with negatives. Just up and down is negatives. We know it's a net. So let's just take a quick look to make sure if we have this right. We know it's an upside down V, so we know that it has a reflection. That's the negative. And has a slope of 3 over 2. So there's your 3 over 2. The vertex is 2 to the right, so -2, and +3. So that's up 3. Good. Domain. Domain is how far left will the graph go, how far right will the graph go, and there's no breaks in between. It's a continuous graph. So -infinity to infinity. The range, how low can the graph go? It goes down forever, both the left and right arrows. So it's going down to -infinity. What's the highest y value? It's at vertex. The y value there is at 3. There's an actual point there, so it's going to be equal to 3. That's what a point means. It's equal to that. All right, moving on. Zeros. Looks like we have 0, 0, and 4. Don't put it in don't put parentheses around that. Then it would be a coordinate 0, 4. So just put 0, 4, or you could put 0, 0 and 4, 0. Either one. Y-intercept looks like it's at 0. Crosses the y-axis at 0. And there's your 2C. Let's move on to 2D. So it's very, very similar. So first we need to find the vertex. So the vertex, no right or left. Looks like just an up 2. So up 1, 2. Then is there a slope in front? Nope, no slope. So that means that there is a slope still, but the slope is going to be 1 over 1. So that means up 1, right 1, up 1, right 1. So no dilation at all. And up 1, left 1. And so now we have that part. Now we're not going to automatically draw a solid line here. It's less than equal to. If there's an equal to, that means solid line. Just like last, like 1 through 4, that was equal to, so it was a solid line that we draw. If it's not equal to, then it's dashed. That's how you can tell the difference. All right, so now we got to look at less than. What does that less than do? So less than symbol, and it kind of looks like an L, so less than. Kind of a mnemonic device way to think about it. Now less than, where do you think less than would be shaded? Should be below less than. Less than is below. You can always choose a point anywhere in this shaded area, and it will work for that inequality. So you can choose any coordinate you want. Like, I'll do that just so you can see. So I can choose any coordinate I want, like 0, 0. That's in the shaded area. So x is 0 and the y is 0. If we substitute that in, so f of x is y. So I replaced x with 0 and the y was 0. This should be true. Is 0 less than, absolute value of 0 is 0, plus 2 is 2. Is 0 less than or equal to 2? Yes, good. Then that's in the shaded area. That's a solution. Anywhere in that orange shaded area is a solution. So I guess we have points here, 0, 0. Choose any point you want. That is in the shaded area. Let's go over here at negative 1, 2, 3, 4, 5, 6, 7, up 4. So negative 7, 4. You could also choose a point on the actual line because it's equal to. So you could have done something like 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, 6 also would work. Just nowhere, just not somewhere in the non-shaded area. Shaded area, or because it's a solid line, that's part of the solution also. All right, moving on to number 6. So we're going to go left 3, up 5. That's your vertex. Got your slope, 4 over 1, so up 4 to the right 1, up 4, left 1. It's not equal to, so it's going to be a dashed line. Very skinny. Slope of 4 is very steep. Now we have a greater than symbol, so that means we're shading above or the line. So above the line should be somewhere in here, very, very, and it keeps going forever. All right, solution points. This is going to be a little trickier because it's a dashed line, so that means there's no solutions on the actual V. Let's look very closely. Looks like inside there we have whatever that point is. So that's negative 3, 1, 2, 3, 4, 5, 6, 7, 8. Negative 3, 8. And I guess I could just even go one up from that. Negative 3, 9. Anywhere in the shaded area is a solution. Not on the actual line and on the V in that case. All right, next one. Write the equation of the inequality. All right, so still find the vertex. Vertex is here, 2, 7. So that's right from the origin, 2. So in the equation, it's going to be x minus 2, up 7. So it's a plus 7 on the outside. Notice I haven't written, and now the next thing, look for the slope. So our next coordinate from the vertex would be down 1, 2, and over 1. So down 2 over 1, down 2 over 1. So that'd be a negative 2 as a slope. It's a solid line, so we know it's equal to, and it's shaded above, so that's greater than. So the y is going to be greater than or equal to negative 2 times the quantity of x minus 2, or the absolute value of the quantity of x minus 2, and plus 7. Solutions anywhere on the actual line or in the shaded area. So 1, 5, that's a solution. That's the actual point right here. It could be 0, 3. Or it could be 10,000 to the right and 10,000 up. That would work because that's like way up somewhere, way off, but it's shaded above, so that would work. All right, last one. Write the equation of the inequality shown below. So let's find the vertex first. So that's to the right 3 and down 4. So right 3, down 4. It's a dashed line, so we know it's not equal to, and it's shaded below. Oh no, never. Before we do that, let's find the next. Let's find our vertex and our slope. So it looks like it's 1, 2 to the right and 1 up, or 2 up, 1 to the right. So it's a slope of 2, and it's shaded below, so that's less than, no equal to because it's dashed, and y. Solution point anywhere in the shaded area. So like go down here, 0, -5, not on the actual line because it's dashed. Dashed means not part of the solution. So 0, 0, that's in the shaded area. And there's plenty of other ones. All right, hopefully this helped you.